Okay, you do a little bit with sequences when you're in Algebra 1. You learn just very basically how to write the equation of two different types of sequences, and then we're going to get into the thick of it this year. All right, a sequence is an ordered list of numbers generated by a function. Okay. The domain of the function is the set of positive integers. The values in the list are what are called the terms of the sequence. The values in the list are called the terms of the sequence. We usually use an A or a U to represent a term. A term's position in this list is represented by N. Okay, so on the bottom here are the positions of the terms. First, second, third, fourth, fifth, sixth. These are the positions of the terms. The top numbers are the actual numbers in the sequence. So top numbers is the actual sequence. 1, 3, 5, 7, 9, 11. So the bottom numbers, we use the variable n to represent these. It's kind of just like an x value. Just instead of x, we use n for sequences. And similar to x. Okay. And then the top number, the actual sequence, we usually use A with what's like a little subscript on it, AN, like that for sequence. It really just means Y. These are the Ys. These are the Ys, similar to Y. Similar to Y. So instead of X and Y for sequences, they use N and AN, or sometimes they use different letters. I like to switch it up. Types of sequences. Sequences can be what are called finite, or they can be infinite, which is infinite. Finite or infinite. A finite sequence has an ending. You can see it, 2, 4, 6, 8. That's it. Those are the only numbers in our sequence. Whereas infinite, can you see the difference? We've got that dot, 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 which means it's going to continue on. Both of these sequences would follow the same rule. It's just one of the rules, one of the sequences is finite, one is infinite. The rule for both of them is an equals 2n. Notice this is just like a little tiny linear function. For a linear function, you would probably write y equals 2x, but for sequences, they like to use an and n instead. So it's just 2 times the numbers placed in line. That's how we would find the sequence, any more terms of a sequence. So for the first ones, we're given a rule to follow, and we're asked to find the first 4 terms of the sequence. Okay? These are definitely not linear sequences. This one would be a cubic function. You can see it has that cube exponent. The bottom one, does anyone know what type of function this one would be? It would be a rational, right? So there's variables on the top and bottom. These are what are called the explicit rules of a sequence. The explicit rules basically means to find specific terms, you can plug in the position as the independent variable. So like if I need to find the first term, I would just plug in the number 1. If I need to find the second term, I would plug in the number 2. If I need to find the third term, I would plug in the number 3. Very good. All right, let's try it. Let's find our first, second, third, and fourth terms of this one. So again, to find my first term, I'm just going to plug in the number n equals 1. And I'm just plugging that into the right side of the equation. I would say 1 minus 3 to the third power minus 2. Oh, minus 2 should not be in my exponent. Delete. Minus 2 is negative 10. That is the first number of my sequence. Okay, to find my second number of my sequence, what are we going to plug in? 2, very good. N equals 2. 2 minus 3 is? No, negative 1. What's negative 1 to the third power? Negative 1. And what's negative 1 minus 2? Negative 3. For the third term, we're going to plug in n equals 3. Anyone think it's just going to be 7 higher? No, because that's not a linear sequence. This one's cubic, right? So 3 minus 3 would be 0. 0 to the third power is 0. Subtract 2, we get negative 2. Okay. And then lastly, my fourth number of my sequence, plugging in 4. 4 minus 3 is 1. What's 1 to the third power? 1. 1 to the third power is 1. 1 times 1 times 1. And then what's 1 minus 2? Negative 1. Okay. For the second one, we're using the function rule, which is a rational function. We're going to use it to find the 50th number in the sequence. So what number are we going to plug in? 50. Yay for explicit rules. Plug in n equals 50. So we'll have 50 squared over 3 times 50 plus 1. It's going to be 2,500 on the top. Over 150 plus 1, 151 on the bottom. Very good. Okay. The next new definition, okay, so we learned what a sequence was, bless you. The next new definition is a series. There's our new word, a series. That's part of this unit. A series is basically a sequence, but instead of having a comma in between the terms, what does it have instead?
Series. Plus.
A plus sign, right. A series is basically when the terms of a sequence are added together. You can see all those plus signs in between. Okay, see those plus signs? Again, series, just like sequences, they can be finite, so they can have a stopping point, or they can be infinite and not have a stopping point. For series, we use a new kind of notation. This notation is called summation notation to write a series. All right, so this is the one I remember someone saying at the beginning of the unit that it looked like we were doing calculus, but it's just a different type of notation. Okay, so we have that series notated here, 2 plus 4 plus 6 plus 8. This is what it would look like in summation notation. So this little symbol right here means the sum of. That's what its meaning is. It is a Greek letter. Anyone know what Greek letter it is? Sigma. It's sigma. Aphrodite's is not a Greek letter. Okay, on the bottom, this I equals 1. Sometimes they use I, sometimes they use N for this. It really doesn't matter. It really just is telling you that we're starting with the first term of this sequence, and we're going to the fourth term of the sequence. So it says start with the first term and go to the fourth term of the sequence that follows this rule, 2I or 2N. Again, the letter doesn't really matter. So this means it starts with the first term. Start at first term. The number up top is the term you're going to stop with the adding. So that stop at the fourth term, or goes to the fourth term. Goes to the fourth term. And then right here is the sequence rule. And again, the letters that they're using, they switch it up a lot. I's, N's, I've seen U's. The letter really doesn't matter, but it just is telling you this is the sequence rule that it's following. Right? And then if we look how the next one is different, this one was an infinite series because it had that dot, dot, dot. So how did we change it? It goes to the infinite term. Very good. So we would write this series like this in summation notation. Yes, hon? Yeah, that would be the third term. It doesn't end. It goes to infinity.
Well, like, if you're writing it.
Yeah, that part doesn't matter. All right, we're going to try a couple of these. They're written in the summation notation with the sigma, and we're asked to find the sum. And so this first one says that I need to start with the first term of the sequence, and we're adding all the way up to the fifth term of the sequence that follows this rule, 2I plus 5. So I know I'm adding the first through the fifth term, so I'm going to write out 2, 3, 4, 5 blanks. If you're clicking your pen.
Okay.
Thank you. Okay. And we're going to need to find their sum, basically, of whatever that first through that fifth term is. Okay. So starting with the first term, very good. For the first term, I'm going to plug in I equals 1 to this little function rule here. So if I did 2 times 1 and then added 5, what would my first term be?
7.
7, yeah. So there's my first. Okay. And then for the second one, I'm going to plug in I equals 2. 2 times 2 would be 4, plus 5 would be 9, just regular 9.
Just type in. Whoa, I need the
All right, for the next one, I equals 3. So we're doing 2 times 3 plus 5, which is 11. You can actually see this one does follow a visual pattern. Do y'all know why it follows the visual pattern?
But it starts at 7.
Yeah, because it's a linear function.
Whoa.
A linear function, I can see the changes too.
Sorry.
So I equals 4 would be 13. I equals 5 would be 15. Now remember, the summation symbol literally means you need to find the sum of these now. Okay, so once we find the terms, we need to actually add them up to find the sum of all of those. 55. Very good. There's our sum. So again, this notation means start with the first term, go to the fifth term. It's going to follow this rule, but then you also have to find the sum. So it's like a weird way of telling you 4 different things.
Well, I know what the next one is.
All right, looking at the next one. Yes, you start with the fourth term, but what's our starting term? 0. So we'll have when I equals 0, when I equals 1, when I equals 2, when I equals 3. Yep, I equals 0 all the way to I equals 4. I equals 4. Correct, yeah. This doesn't necessarily tell you how many there are. Okay, starting with I equals 0, that would be 0 divided by 0 plus 1, which is 0.
What? Oh.
Because you have a 0 on top, Sean. The second one, it would be 1 divided by 1 plus 1, which is 1/2. Very good. The next one would be 2 divided by 2 plus 1.
And you too. No, it's like
2/3. It is definitely not linear. How can we tell this is not linear?
Because it says ratio.
It's a rational function, yeah, because it's a ratio, it's a fraction. It's like unit 6. And then we got 3 over 3 plus 1, which is 3/4. And then the last one would be 4 over 4 plus 1, which is 4 over 5. Very good. And remember, the very last thing you have to do is literally add them up. The summation symbol means once you find them, add those up.
It's gonna be like really, really, really quick.
Let's figure it out. 1/2 plus 2/3 plus 3/4 plus 4/5. It's not really close to 1, Danny. It's above 1.
Yeah, getting smaller.
Oh, okay. It's getting bigger. 163 over 60. What's your question?
0. With 1, right?
Mm-hmm.
Although each number in the sequence does get like really close to it.
Mm-hmm.
It just never will. It's like a
All right, the next part is basically throwing it back to Algebra 1. Okay, there's 2 main types of sequences. There's actually a bunch of sequences, but 2 main types of sequences that we're going to look at. The first one is what's called an arithmetic sequence. It looks like the word arithmetic, but for some reason for sequences we pronounce it slightly differently. We say arithmetic. An arithmetic sequence is actually a linear function.
Didn't we do these earlier in the year, like at the very beginning?
And an arithmetic sequence has what's called a common difference. Common difference, which is kind of like the slope. And that common difference will be constant all throughout the terms of your sequence. Okay. You can actually see that up here. How much does it change by each time? 2. So that would be your common difference. It changes by 2, so that's your common difference. And then the second main type of sequence that we look at is what's called a geometric sequence, which has nothing to do with geometry. Geometric sequences are actually exponential functions. exponential. And a geometric sequence has what's called a common ratio, so some number that is multiplied each time, and that common ratio will be constant. Ratio is constant. So for arithmetic, a linear function, you'll have some number that is added or subtracted each time to get from one term to the next, to the next, to the next. And a geometric sequence, you'll have some number that is multiplied by each time to get from one term to the next, to the next, to the next. So looking at these three here, we're trying to figure out whether they would fall into the arithmetic category or if they would fall into the geometric category. So we're checking to see, is something being added or subtracted each time, or is something being multiplied each time to get from one term to the next, to the next, to the next? For this first one, what are we thinking? Right, what number is being added each time? 9, very good. To get from 5 to 4 is plus 9. 9 to 23 is plus 9. Plus 9, very good. This would be arithmetic. The variable that we use to represent the common difference is the letter D, so we would say D equals 9. For the second one, what are we doing each time? Divide by 2. So would that be arithmetic or geometric? Geometric. Now for geometric, we want to write it as what we're multiplying by each time. What are we multiplying by each time? 0.5. Very good. A half each time. So we'll say geometric. So for arithmetic, the common difference was the variable D. What do you think our variable is going to be for geometric? R for common ratio. Yeah. R equals 1/2. Lift your head, please. All right. Next one. 1 to 2, 2 to 3, 3 to 5, 5 to 8, 8 to 13. Neither. Yeah, it's not adding or subtracting anything each time. It's not. To check if it's multiplying by the same number each time, I can see the first one would be times 2. And then is the next one times 2? No, so it's not multiplying by the same number each time. So this is still a sequence. It's just not one of these two main types of sequences. It would follow some sort of other function pattern. Quadratic, cubic, something or another. United. For arithmetic and geometric, we are going to review how to write the equation for it, which would be like the rule that it's following. Straight from Algebra 1. Geometric sequences, again, we said they were exponential functions. So looking at how we would find their rule would have an, which an, remember, just means kind of like y equals. And then we'd have a1, where it says a1 is the first term of the sequence, times our common ratio, to the power of n minus 1. And that n is kind of like an x value, so you could just write x minus 1. Jillian, you need to wear your glasses. You're going to get wrinkles from squinting so much. Okay. Arithmetic sequences. This is the one that would be a linear function. So we can look at its equation here. It says an, which is just like your y equals a1, which is your first term of your sequence again, plus n minus 1, which is kind of like having an x minus 1, times that common difference. Okay. What? Okay. Okay. Looking at the first one, we're going to first start just by seeing if we can figure out whether it's arithmetic or geometric. Is it adding or subtracting a number, or is it multiplying by a number? It is adding. What is it adding each time? 5. Very good. So arithmetic. Okay, so for arithmetic, we'll need the equation an equals a1 plus n minus 1 times the common difference. Okay. So the two things we need to write this equation, we need the a1 and we need the common difference. The common difference is 5, and the A1 is -4. And so we're going to take those two numbers and we're going to substitute them in. We'll have AN, which is just like a y equals -4 plus n minus 1, which is kind of like an x minus 1, times the common difference, which is 5. This equation, I do want us to simplify these. We actually don't have to simplify the other ones, but for arithmetic ones, I do want us to simplify. What could we do to simplify this? Distribute the 5. Very good. It's kind of like backwards from where we normally have the distributing. 5 times n would be a plus 5n. 5 times -1 would be -5. And then there's one last step to get it in its final. Yeah, combine the -5 and -4. And then if you want to write it as 5n minus 9, if you want to write -9 plus 5n, it's up to you.
We know that we can't just leave it.
No, I want it simplified. The simplifying is literally algebra 1. Wayne. All right. Second one, again, first thing we want to figure out is whether it's geometric or arithmetic. Geometric. If you ever have trouble, geometric. We almost had it right. Geometric.
I know the numbers. Geometry.
Okay. If you ever have trouble figuring out what the R value is, you can take any term in the sequence and put it over the term right in front of it. So again, if you ever have trouble figuring out, you can take any term in the sequence. So like if you take the last term and then put it over the term right in front of it, that's what your common ratio is. So the two things we need in order to write the equation, we need the R, which we know, and we need the A1, which is the first term. Okay, we're going to substitute those two into our equation. So we'll have AN, which is like a y equals. Then we'll have our A1, which is 625, times our common ratio. I'm going to purposely write this answer wrong, and then I'm going to see if y'all can figure out what I'm doing wrong. To the power of n minus 1.
Didn't put the 1 over 5 minus, or no?
I put the 1 over 5 minus, what do I need? Parentheses. If the base on your exponent is a fraction, you need to put in parentheses. To get around that, if you want to write it as a decimal, you can get around it like that. Now, because otherwise you're only putting the exponent on the top instead of the whole fraction.
Awesome.
Now, this equation, this one, Justin Blake. This equation actually does simplify. This one does. Not all geometric sequences do simplify, so I'm not going to have y'all simplify the geometric one. Okay, this one actually does because both of these can be rewritten as a base 5. You can write them with both, but I'm not going to have us. No need to simplify these. Please do simplify the arithmetic ones, but I'm not going to have you simplify the geometric ones. How are we doing on time? Perfect. Good. Sure do. These two are just from Algebra 1, though. Really?
Never learned this in my
Oh, good. Okay, one last one. Find the rule for the arithmetic sequence. Okay, and what this says is this basically is telling me the third term is -2 and the 17th term is 40. Okay?
Well, it's just 17 minus 3, and then find the average, like, okay, wait, so 17 minus 3, so there's 14 terms there, and then find 40 minus -2. So you have to do 42 divided by 14 terms to find the rate of change. It's just,
Well, Danny's finding a rate of
it's just
change. It is just slope. It is, yeah. It's kind of like doing a slope.
I got the answer.
Okay, ooh, you got the answer for the slope? Okay, yeah, it's kind of like, these two are basically kind of like point. Okay? So this is telling you the third term is -2. So my third term is -2. Okay? This is telling you my 17th term is 40. My 17th term is 40. So it's kind of like points. So if we need to find our common difference, we actually are just finding the slope of this. So it's an arithmetic, so it's linear. Common difference.
Wait.
Hold on, Jenny, hold on. Is basically the slope. Okay. Alright, so do you remember how to find slope of 2 points?
Y2 minus y.
It's definitely not a distance formula. Y2 minus y1 over x2 minus x1.
So this is just a linear.
Arithmetic sequences are linear, yeah.
It's just linear.
Alright, so we got, let me see, 40 minus negative 2 over 17 minus 3. 40 minus negative 2 is 42. Divided by 14 is 3. So again, this is our common difference. So our common difference is 3. Okay. Alright, so, I have part of my rule. What else do I still need to find in my rule? Yeah, I'm gonna find your first term. So basically, it's almost like finding like the y-intercept. Technically, it's not the y-intercept, but what can we do to find that? Do what? Well, we have an equation. We have an equals a1 plus n minus 1 times d. Plug it in for which two variables? N and an, yeah. You can pick either of these points to plug in for n and an, and then you can also plug in the fact that you know what your common difference is now. I'm going to call this one the n, this one the an. There might be a little subtracting in there somewhere. We'll see. So 40 equals a1 plus 17 minus 1 times the common difference, which we found was 3, is what over? Plus, that would be 16 times 3, which is 48. So that means my a1 is negative 8. All right, we found both of the things we need for the equation now, so what else do we still need to do? Yeah, literally write the answer. So again, we're going back to plugging it in here. So we'll have an equals our a1, which we know is negative 8, plus our n minus 1 times our common difference, which we know is 3 because it was a linear function. And then for arithmetic, I do want you to simplify. You don't have to simplify geometric ones, but arithmetic we do. Negative 8 plus 3n minus 3. So our final answer would be 3n minus 11. This is literally just one way to do it. Last year, whatever period this is from last year, we did it using a system of equations. And we plugged in our x's and y's to write a system of equations, and then kind of the same thing. We found d, we used d to find a1, and then we wrote our equation. Looks like the same amount of work either way.
Simple, can we get you back 3